Hello, welcome to a video discussing section 4.7, which is on completing the square. So sorry for any background noise. I'm actually doing this at a Starbucks next to Levi's Stadium. Heading out to Monday Night 49ers game, so that might be a Google form question. Just keep that in mind. Anyway, so we're asking to find the missing term. So if we look at what we got here, we got x plus 3 squared. Now remember, that's x plus 3 times x plus 3, right? Anything that's squared, you want to multiply by itself. This requires a FOIL process. Well, what is the FOIL process? First, outside, inside, last. X squared plus 3x plus 3x plus 9. Combine like terms, you get x squared plus 6x plus 9. So of course, the term in the middle is 6x. Now there's a reason why we're going through this exercise. That will become clear after a few minutes. But for now, we're just doing things that you guys should be familiar with, the FOIL process. And remember, please, please, please do not do this. This is terrible. Do not think that x plus 3 squared is x squared plus 9 and call it a day. That is not true. Remember, if you had 2 plus 3 squared, you wouldn't say it's 2 squared plus 3 squared, right? You would totally not say that. You would say 5 squared, which is 25. That above would be 13. That's a problem. So you got to make sure we FOIL and that we respect the order of operations. So let's move on to part B. These should be pretty simple. If you work that out, that's going to be 16. Now this was a little weird, but if you have a 1, there's going to have to be a 1 right there. And if I do x plus 1 times x plus 1, I wind up getting 2x in the middle there. Here, if I have a negative 10x, most likely that probably came from x minus 5 times x minus 5. So that's going to be a negative 5 right there. And of course, a positive 25 right there. So what we're trying to do in this exercise is making sure that you're comfortable with a binomial squared. And what does that lead to? A perfect square. Trinomial. Let me spell that again. So essentially what's happening, if you look at the next example, is that we're trying to generate perfect square trinomials. And generally speaking, if you have a plus b squared, it's going to look like this. Or if you have a minus b squared, it looks like this. So you can think of the x squared like the a squared, the 14x like the 2ab, and the c here like the b squared. So if we think about it very carefully, that's like 2ab, that's like a squared, and again, that's like b squared. Hopefully you gather a is x. If a is x, then you're going to have 2 times x, and probably going to have to do a times 7 to make that a 14x. So b is 7, therefore your b squared is going to be 7 squared, which of course is 49. So the value of c here is 49. Now, one technique you could do is take half of the coefficient of x and square it. So if I took half of 14, which is 7, and it's 7 squared, of course I get 49. Why the half? Because there's a 2 right there. That's part of the perfect square trinomial expansion. You take a binomial like a plus b or a minus b, when you square it, you're going to have a squared plus b squared, of course, on the ends, but in the middle, you're going to have the 2ab. So if you actually were to take half of whatever this is right here, that eliminates a 2-bit, and then if you square both sides, that is actually going to help you get the last part. Now, let's take a look at another one here. X squared minus 22x plus c. You can take half of 22, which of course is 11. 11 squared is 121. So c equals 121. Now, you might be asking yourself, well, there's an a and a b, right? That is a little confusing. When we had negative 22x, it's like saying negative 2 times x times 11. Remember, that's the a, that's the b. So when we take the half part, of course, we see that these cancel. And I'm kind of just deliberately dropping the x because that's part of a squared, and just focusing on this part right there. That helps me get the b squared, which is the constant at the end of the trinomial. Let's do this again. Half of negative 8 is negative 4. Negative 4 squared is 16. So c equals 16. Half of 9, this is going to be a little weird, is 9 over 2. 9 over 2 squared is 81 over 4. So c equals 81 over 4. Now, why do we care about this? Why does this matter? It matters because when you have, say, x squared plus 14x plus 49, you can write it as x plus 7 squared. So basically it's a perfect square trinomial. And when you have a perfect square trinomial, like a squared plus 2ab plus b squared, you can factor it as a binomial square. So very important. Perfect square trinomials can be factored as a binomial squared. Now remember, bi means 2, so it means you have 2 terms. Tri means 3, you have 3 terms. And perfect means that the first and last terms are perfect squares. And a binomial squared, of course, is you take 2 terms and you raise that to the second power. One thing that might help, if you do look at our notes for the previous unit, the factoring flow chart, when you have 3 terms and you pull any common factors, are the first and last terms perfect squares? If they are, then you can factor it like this. But with one condition, you make sure the middle term is twice the product of the square roots of the first and last terms. So right here again, 2ab, the square root of a squared, b squared, a and b respectively, multiplied by 2. So as long as that's happening and the first and last terms are perfect squares, we can factor it this way. It's advantageous for solving quadratic equations. Now, we're not going to talk about quadratic form just yet, so let's actually erase that. Let me show you the process here. Now, this process is called completing the square. And here's how it works. You're going to push the 3 off to the side. So what you're going to want to do is move the constant to other side of equation. Then you're going to take half of the coefficient of x and square it. So it's going to be x squared plus 14x equals 3. And then you're going to do plus 49 and plus 49 on the other side. Remember, it's got to be equal treatment, so you got to make sure you do it to both sides. Then you're going to factor the trinomial. And trust me, it has to be factored, because if you can't factor it, you didn't do the process right. And then you're going to solve by square rooting both sides. So if we do that, you have x squared, x plus 7 squared equals 52. X plus 7 equals plus or minus root 52. So notice I square rooted both sides here. And then when you isolate x is negative 7 plus or minus root 52. Now if you wanted to, you could use the quadratic formula. X equals negative b plus or minus b squared minus 4cl over 2a. You might remember that from middle school. But we're not going to do that just yet. We'll do that actually later this week. I want to make sure you guys really understand the completing square process, because completing square actually explains why the quadratic formula works the way it does. Let's try this again. So what I'm going to do is, again, move the constant to the other side. And now in this case, if a does not equal 1, divide both sides by a. So everything's going to get divided by negative 1. X squared minus 4x equals negative 5. Take half of b, and then negative 2 squared is, of course, 4. Add 4 to both sides. Then we factor. Remember, it's a trinomial, perfect square trinomial, so you can factor it like that. Then you square root both sides. X minus 2 equals plus or minus, now remember that's I, it's an imaginary number. X equals 2 plus or minus I. Now I am going to show you guys when we meet again in class how you can actually use the graphing calculator to verify your answers. There's actually a really cool app that's built into the TI-84 graphing calculators. If you do want to experiment with it, the app is PLY SMLT2. If you go to apps, and you're going to pick a poly root finder, I think. Give it a try if you like, but I'm going to show you guys how it works when we meet again as a class. Okay, let's talk about some other applications of completing the square. So this is really the main process we're talking about, completing the square. It's called completing the square because what you're doing is you're taking something like x squared minus 4x and making a perfect square trinomial. Almost like we have this in the Google form. A perfect square completing the square is deliberately making a quadratic expression a perfect square trinomial. So that's the whole process. Actually, I'll write it out. So deliberately make a quad expression a perfect square trinomial. And why is that important? Why do we care? Why do we care? Because it's easy to solve by square rooting both sides. That's why we care. And that's what we just did right here. So instead of using quad form, and of course these are not factorable given how the answers look, that's what we do. And by the way, it always works. The completing the square process always works. Doesn't matter what you got. So here are a couple of other applications. You can use this to write something in vertex form. Remember what vertex form was? Oh, what do you know? X minus h squared. That is a binomial squared. Okay, so here's what we're going to do. We're going to focus on the x squared minus 10x and push the 22 off to the side. You can put 22 on the other side too if you like. It's up to you. But I really want to focus on x squared and x. Take half of negative 10, which of course is negative 5. Square root of negative 5, which of course is 25. But you better add it to the other side. So what do we got now? Y plus 25 equals, see now I can factor that. All that becomes this. And there we go. And these are actually the same equation. So this can be very, very helpful, especially because what if you tried doing negative e over 2a? What if you forgot that formula? But if you did, just to verify that we did this correctly, you get 5. Plug 5 in. you get -3. So hey, so it works. Our vertex is 5, -3. So you don't have to necessarily do the negative b over 2a thing anymore. You can just take anything in standard form and write it in vertex form by using the completing the square process. So this is a technique that's going to really have huge dividends in the next 2 years of math, and maybe even when you take some more advanced college math classes. And I'm going to probably ask you guys to use this process often throughout the year, because I don't want you guys forgetting it. I really want you guys to retain it and know it and understand why it's so important. Let's look at number 6. Let's try it one more time, or you can pause the video and try on your own. Let's push 17 off to the side. Take half of -8, which is -4, but square it, which is 16. Remember, half of -8, -4. -4 squared is 16. Y plus 16 equals x minus 4 squared plus 17. Y equals x minus 4 squared plus 1. All right. We got our vertex, which is 4, 1. So that actually makes this equation pretty easy to graph. We got 4, 1. And then you make a quick table, say like 3 and 5. I can plug into the vertex form. It's going to be a little easier. I get 2 in each case. And by the way, there are no x-intercepts. So if you actually were to try to solve this by setting the equation equal to 0, or saying y equal to 0, you end up getting x equals 4 plus minus I. Which kind of makes sense that, you have no x-intercept, so your solutions are not real. So we're going to talk more about that kind of algebraic and graphical connection later in this unit. But I think this concludes the video. So you've learned about completing the square. We've, reviewed kind of a bit of factoring. And that's why, factoring is kind of a big deal. That's why we spend all that time on factoring. So if you're having trouble with factoring, please see me and talk to me, because it is going to make this section really, really tough if you don't feel like you have a strong grasp of factoring. So please talk to me. I'm willing to help you and make sure to get over that hurdle. But factoring is going to have to be second nature now. It cannot be anything that you struggle with. So this is a new technique. Completing the square involves some factoring and solving a quadratic equation. And then we'll talk more about how this all connects graphically when we get deeper into this unit. Okay, well, enjoy the rest of the evening. And I cannot end this video without a football prediction. Monday Night Football prediction. And sounds kind of weird I'm going to say this, but I think the Niners are going to lose tonight. Yeah, we'll see. Maybe I'm wrong. But I say it's be 23-20 Giants. That's what my model says anyway. So, anyway, you guys have a great night, and I'll see you guys tomorrow morning. And if I'm pretty exhausted, you'll know why. All right, see you.